Hello, I am Alessio Ferrari and I am presenting this work on judgment study for the comparison of formal tool for system design. Here is the whole paper in one slide. So we are dealing with the context of formal methods and tool for railway system design. So we are in the railway domain. The problem that we are addressing is that tool selection for railway companies is particularly difficult because there is a large numbers of tools available in the market. The solution that we are providing is a judgment study with 9 tools and 17 experts with the goal of providing some guidance for companies that want to introduce formal methods within their development process. There is a result of this analysis that each tool is appropriate for a specific railway development context that may depend on the phase of development, on the type of system that I need to develop, and other aspects. We contribute with a table to guide when to use a certain tool and what are the typical issues that may emerge when adopting a tool for system design. So the context is formal methods and tools. What are formal methods? Formal methods are mathematically based techniques for specification, development, and verification of systems, and they are normally supported by formal tools. These formal methods and tools are highly recommended for railway safety critical products by the railway norms. But there is a large number of tools available. Here you see just 3 examples, but you already see the differences in terms of modeling languages that are used. Some are textual, some are graphical, some are based on blocks, some are on transition systems. So for a company to decide which tool is appropriate for their needs is particularly complex. That's why we started this project that is called Astrail. It is a European project, so we started it to provide some guidance for companies in the selection of formal tools. We first performed some empirical studies with a systematic literature review, a project review, and a survey with practitioners, and then we identified a group of tools that are particularly important in the railway domain according to the literature and the practitioners. And based on these tools, we performed a tool review. A tool review consists on a judgment study, usability analysis, and a systematic analysis on the technical features according to the DESMET methodology. Here in this presentation, I will focus on the judgment study. This is the design of the study. We started, the design is composed of two main phases, an evaluation phase and an assessment phase. In the evaluation phase, we involved 3 designers and we asked them to model a simple railway system and to reflect on the issues encountered with the usage of one of the 9 tools that we considered and when it was more appropriate to use that specific tool. And we asked them to provide reports on their experience. Then they met in a focus group to update the reports and to discuss on the experience itself. The output of this evaluation activity was given by 2 other experts in both formal methods and railways, and they performed a thematic analysis of the content produced, and they provided a table, an evaluation table for the tools. Then this table, the content of this table, was further assessed by a group of experts in each specific tool that allowed to come to a consolidated evaluation table. And the table is here. This is a comparison table. You see that it's very synthetic and it's very simple because it is mostly oriented to low and middle management. So few information to actually know when it is appropriate, in which context is appropriate to use a specific tool. For example, you see that there is a column for the purpose, whether it's modeling, simulation, or verification, and the phase, for example, because a tool is more appropriate for prototyping, so more appropriate for the requirements phase, and another tool has powerful code generation capabilities, so is more appropriate for the implementation. Here, the emphasis is on relevance, so we are not focusing on all the capabilities of a certain tool, but the ones that are more important for that specific tool, are the strong point of that specific tool. And we found also several issues related, for example, to the absence of a GUI or to problems in the language, for example, the absence of hierarchy or no support for parallelism. Here you have a list of implications for practice and research. The green ones are the implication for practice. Here, the first implication is that now practitioners have some guidance, particularly oriented for low and middle management for the selection of formal tools for their development process. One crucial thing that must be highlighted is related to formal methods diversity. So we need a combination of formal methods to address all the needs of the railway development process. At the same time, we need expert diversity. So we need diverse expertise, people who have expertise in the domain, but also in different formal tools. And we have to consider that an expert in a certain tool may not be the right expert to develop a model with another tool. Concerning research, since most of these tools are coming originally from research, what we found is that the main pain points of the tools are related to usability, learnability, and maturity. And these are also the characteristics that, according to the other survey that we performed with practitioners, are the ones that are considered most relevant by practitioners themselves in the railway domain. Also, we are contributing with the research method, because this is the first judgment study performed in the comparison of tools that requires high expertise, and it is particularly appropriate as a design for any study in which expertise is required by the human subjects involved. You have a limited number of experts available, and you are still in an exploratory stage of your research. And finally, another topic that emerged is related to the human aspects of formal design. Here we saw that subjectivity plays a crucial role both in the design of these models, so the background of the people, but also in the assessment of the capabilities of the tool, because we saw that there was disagreement even in some aspects that should be considered well established. For example, the support for parallelism. So it is important to consider how these experts use this tool, and how do they focus on certain features rather than others, because no expert practice with the tool in the same way. Here, as a conclusion and ongoing work, we presented the first judgment study on formal methods applications. The results that we are showing, they point to novel research directions, so tool and expert diversity, but also human aspects of formal design, as I mentioned a few seconds ago, because formal methods are not just about formulas, but are also about people. And this is an aspect that was not considered so much in the past. Other works that have been performed within Astray, so within the project, are the DESMET evaluation, so the systematic evaluations of features for these tools, a usability analysis involving practitioners, and we have also experimented with the formal methods diversity, so combinations of different tools for developing a quite complex railway model. And finally, we are currently involved in this project, which is called for Securail, that is a follow-up of Astrail and is concerned with the cost-benefit analysis of introducing formal methods in railways. And the presentation is finished, so if you want to ask me questions, you're free to ask.